I'm Joe Conway. I work at Amazon on the team that does Aurora and RDS, and my team specifically is the Postgres contribution team at Amazon. So we do the contribution upstream to the Postgres community, right? And compared to working on internal services, we work with the community to make Postgres itself better. So that's what we do. Obviously, lots of feedback from our customers, and one of the major pain points that we were facing was this collation issue. How many people here were at Jeremy's talk yesterday? Not so many, okay. All right, so I'll have to repeat some of this stuff. Anyway, I gotta turn this back on. You can see my Amazon email address and my personal email address. You can reach me at either of those places, and I will be happy to follow up with you if you do. So first, we're going to start out with talking about what is the problem with glibc and collations, and then kind of the standard way that people would fix it when they run into it. And then I'm going to describe in a little bit of detail an alternate approach that we came up with at Amazon and have deployed actually quite successfully, which is open source, by the way. So I'll go into that a little bit. So you see this in the back well enough, Jeremy? Text is hopefully big enough? Yeah. Okay, good. All right, so this is the setup. We're on RHEL 7, and I do an initdb to create a new Postgres database cluster, and I start it up. And this is 15.2. I created these slides originally a couple of years ago, but it's really no different on Postgres 16 or 17, except in a way that I'll mention about 17 when I get to it a little bit. Hey, Jeff. So once you do that, this query that you see here, and again, these slides will all be available so you can repeat all this stuff yourself, but you can see this query is going to show you that your database encoding for that database by default, after you just did an initdb on a kind of a standard Linux RHEL 7 system, is going to be UTF-8, ENUS UTF-8, with a call version of 2.17. Jeremy, I was going to mention, when you said that glibc has no way to inspect the version, you're actually not quite correct. It does. That's where you get that 2.17 from. It comes from a glibc call. There's also a function it's not in all of the older versions of Postgres, but in the newer ones, there's this database collation, actual collation version, which will give you that actually calls the glibc version function and gives you what glibc says it is right now. So the dat call version is the version that Postgres thinks you have of glibc based on initdb time. And the actual call version is coming from a live call to glibc. Sure. Do you know off the top of your head if glibc also has functionality at the batch level too? I'll get into that. The short answer is no, but in the collation compatibility library, yes. Okay? So if you do the same exact thing on RHEL 9, you'll get very similar results, but you notice the difference here is that we're on glibc 2.34. And again, if you had attended Jeremy's talk yesterday, you would have learned that glibc 2.28 changed a lot of things, and that's kind of the famous thing. I think, is everyone here familiar with the concerns around glibc 2.28 and collation changes? Is anyone not familiar with that? So that's what most people have heard of, right? Everyone heard that the sky is falling if you change past glibc 2.28. But the fact is that every major version of glibc, which is basically every time you change OS version, there are some collation changes. But so this is where we start. If you're on one system versus the other, that's the main difference. So as I've said before when I've given this talk, this is my in-your-face slide. If you think simple things that you're doing in your database are not affected by these collation changes, think again. And again, Jeremy alluded to this yesterday, but you can see we have just 3 simple strings, and on RHEL 7 and RHEL 9, they sort differently. Okay, so now we'll get into it a little, one level deeper, and that is I'm going to create a table, which is a single column, and I'm going to make that the primary key. Just keep that in mind, which means it shouldn't have duplicates in it, right? I'm going to insert these same 3 values into that table, and then when I select from it in order by that column, you'll see on RHEL 7 I get the same order that I got before when I just did the simple sort of the strings, right? So no big surprise there. Okay, so now I do like an OS upgrade in place, or I do a PG-based backup, and then I restore that base backup on a RHEL 9 system, and I start up Postgres. And what's going to happen? Well, when I first run that query, you notice the order hasn't changed, right? It's still the RHEL 7 order. And you say, I wonder why that is. Well, so now I go ahead and say, well, all right, let's insert a value, and it just so happens that this is a duplicate, and that's a primary key, and it happily just takes it. All right? So now you realize someone told you, hey, you should reindex your indexes because you did this OS upgrade, right? And you go to reindex, and you get an error. Hey, now I've got a duplicate key. I can't reindex. So now what do you do? So this is kind of the base problem that you can run into. So if we were to run that same query we had before, at this point, you would see that the database still thinks it's on glibc 2.17, but glibc itself is returning 2.34. No surprise, because that's what we have on RHEL 9. So how do I get out of the mess, right? Well, it's messy. So what I'd have to do is I'd have to first drop the constraint, and which will get rid of drop my index, basically my primary key index. And now I have to identify the actual rows that are duplicated, and I have to pick one and get rid of it, right? And how you do that is going to be up to you. In this case, I assume that the one with the higher CTID here is probably the one I inserted second, and so I just drop that one or delete that one from the table, and now I can add the primary key back. And if I do this alter database, refresh collation version, you get this notice that Postgres is going to update what it thinks the collation is based on now to 2.34. And so now when I do a select by of that column, I get the order that I expected on RHEL 9. So now I've fixed things. I don't know where that came from. Oh, I think that just wrapped poorly. Sorry about that. And when we run that query again, we see that now the actual and the database collation version match. So everything looks good. All right, so any questions about any of that so far?
I'm just wondering, do you know the actual, what is the actual collation change in this case? Like, I don't actually understand why that order changed. What was the...
That's where you should have gone to Jeremy's talk yesterday. There are changes that occur for a lot of different reasons. Sometimes it's because Unicode itself has changed. Sometimes it's because the old version had a bug in it. Sometimes it's because, collations are based on human rules, right? And sometimes the country that controls the rules, like France, decides they want things to sort differently, and it just like time zones change, sort orders can actually change because a country decides that they want it to change. I mean, is that a reasonable way to put it?
Yeah, I think the example from there, the glibc people wanted to bring their stuff in line
With a more recent version of Unicode, yeah.
and I think some of the punctuation and character math, it was like around, I think it was around like his string in the example fixed like a number and a punctuation and a letter. And those were where you saw the changes there. But like, there's all kinds of different reasons.
Okay, so now I'm going to show you kind of a different way of looking at this, and this is where I named the collation torture test. Jeremy has a repo on GitHub where he kind of programmatically produces 26 million Unicode strings that are not like, it's not 100% coverage of every possible sorting for every possible collation, but it's based on his years of experience. He's picked it out to, like, it'll find most things that change. And so basically I took that output from his repo and I had to like escape the quotes or something so that it would load cleanly and copy. And so you can actually get that on my website if you want it. It's already cleaned up, so you can just basically do a copy into a table. Just as an aside, I've mentioned this to a few people here this week. Anytime you bulk copy into a table, you should probably do a vacuum freeze analyze afterwards for a bunch of reasons that I won't go into here because it's not relevant, but if you want to talk to me later about it, I'm happy to do that. And then this query here, what it's doing is it's sorting those 26 million strings, concatenating them all, and calculating an MD5, right? So it's basically going to tell you if any string sorting changes, you'll get a different MD5 value, right? So it's kind of a quick test to say, did anything change in my sorting? And what I want you to remember here is, remember this is RHEL 7, and with those 26 million strings, the sort order is going to produce, with glibc 2.17, this 7E130. You can just kind of remember that because you can identify then when the sorting has changed, right? And the other thing I want you to notice here is this sort of 26 million strings on whatever machine I produced these slides on was about 3 minutes. I've done it on a few different machines, some EC2 instances, a local desktop. It varies between like 2 to 3 minutes generally with glibc 2.17, which again is important. And I've given you, I'll make the slides available, and there's a link to Jeremy's code and to my version of it. Okay, so now if I build an index on RHEL 7 on that unsorted table, and you can see I get a exact same result, so nothing's changed yet. And of course it's much faster. It's like 3 seconds to sort it now because I've got an index on it. But I did that on an index table instead of the unsorted table. And have anyone here not heard of mcheck? Mcheck is kind of an extension for Postgres that lets you check the integrity of certain things, and among them indexes. I don't know if Peter Gagan wrote it entirely, but he's certainly been involved in maintaining it. Did he write that?
I'm not sure if he wrote the original version.
Yeah. Peter Gagan is one of the guys on our team at Amazon, and he's been heavily involved in mcheck because he gets way deep into the B-tree index code. But in any case, when you run that on this index now, we're still on RHEL 7, and you get basically null results, which means it didn't find any problems. So now we're going through the scenario again where we do the base backup, restore in RHEL 9, or just upgrade in place to RHEL 9, or whatever we're going to do. And we run the same sort on the unsorted table. You notice we get a different signature here, which means our sorting has changed. But the other thing I want you to notice, and I'll talk about this some more later, look at this, 56 minutes. I've seen times between like an hour and 4 minutes and down as low as, like on my laptop, I got 53 yesterday. But way slower on the more modern version of glibc. And like I said, I'll get back to that a little bit later. But you also see that, again, I showed you this earlier, but if I do that same select from the index table, I get my original string back, and that's because the index was persisted in the RHEL 7 order. And you can see that's still fast, of course. So I'm not going to allow anyone to do any inserts on this thing, right? So I don't have to, that's kind of the key, is if you do this upgrade from RHEL 7 to RHEL 9, you need to reindex before you let anyone change anything. But you're still going to have corrupt indexes potentially. If any of the characters in your tables have changed their sorting order, when you run amcheck, you're going to see that you get errors reported. And so that's your indication, that's an absolute indication that you need to reindex that table. And again, as long as you haven't let anyone insert or update or do any changes on that table, the reindex should just work. And then after you've done the reindex, you'd see that you get the order that you expect, and amcheck comes back clean. All right, so before I move on from there, any questions on any of that? Okay, so again, Jeremy touched on the fact that there are some other issues besides just indexes that you can run into with all of this. And so this first example is I create a foreign data wrapper, and I point it at my RHEL 7 server from my RHEL 9 server, right? And I write this query that's basically joining a local table on RHEL 9. Now, in this case, I didn't upgrade the database to RHEL 9. I just have, like, I did a dump and restore or whatever. So I have a working database on RHEL 9. I have a working database on RHEL 7. They basically have the same data in them. And I try and do this join of the local table to the foreign table. And what I get is this error that says merge join input data is out of order. It's like, what's up with that, right? And the problem is that the FDW will push down the order by. So the order by happens on RHEL 7 for the foreign table, and the order by for the local table is happening on RHEL 9, and as we've been talking about, the orders are different. Merge join expects things to be consistently ordered in order to do a merge join, so that's going to blow up. And again, I think Jeremy kind of touched on this one. When you have partition tables, if you're partitioning by range, and that range happens to be a collatable data type, right? I've created a partition that's like from min to 1-A and from 1-A to max, right? On RHEL 7, I insert into that table, and you'll see that the data 1A will fall under test partition 1. But if I do that same insert on RHEL 9, it'll go to test partition 2. And so if you're depending on your partitioning scheme to keep your data unique, now you've got the same data in 2 different partitions. Or you did an upgrade and the data is in the wrong partition. So just to review, why is all this important? Why should you care about it? The first bullet says your collation provider is probably provided by glibc in version 15 and earlier. Fact is, it's probably provided by glibc, period. Right? In 15, we made it possible to set the default collation to ICU, I believe, database-wide, right? Or was that 16? 15, that's what I thought. That's why I wrote it this way, I think. So conceivably, you could have a database that's got a default collation that's an ICU collation starting in 15, but the fact is, I don't know anyone who's done that. So I'm sure there are a few people out there, but it's still pretty rare. Most people that provide you with a Postgres database, it's going to be glibc. If you just do what I did earlier, install the RPM, do an initdb, you're running with a glibc as your collation provider. The sort order obviously relies on the collation provider, and the indexes and other things persist this sort order. And some things like merge join depend on the order. And the merge join is kind of an illustration of another concept, which is really anytime you've got distributed systems, if the sorting depends on glibc and then you've got distributed systems, you better hope that all of your systems are on the same version of glibc, which means they probably need to be on the same operating system. They're all RHEL 7. You don't want a mix of RHEL 9, RHEL 7, Ubuntu or whatever, because even beyond just Postgres, anything else that's running distributed, if it depends on glibc for any of its sorting, you may have problems. And the other reason it's important is there's still a lot of people out there probably running on RHEL 7, and it's now already end of life. You can get extended support for it, but it's basically end of life, and so you need to be looking at upgrading. So for all these people that have been running their database on RHEL 7 for the last 10 years, the clock is ticking. The same for Debian 10 and Ubuntu 14. So the problems we need to tackle are the broken indexes. I showed you how to rebuild those things if you need to. And if you've got distributed systems, as I mentioned, that's potentially going to be a problem for you that will be difficult to solve unless you're running a consistent version all around. Okay, so I just wanted to create one slide to talk about a look ahead. Most of the rest of the talk is going to be kind of a look behind, or how do we deal with the current stable versions of Postgres. But in Postgres 17, Jeff Davis, who's sitting here in the audience, was the author and the committer for a new feature called a built-in provider. And so what that allows you to do is use a collation that is basically controlled by the Postgres developers rather than the glibc developers or the ICU developers. So that is, we say that's guaranteed to be stable across versions. It's only guaranteed to the extent that we're successful in doing it correctly, but it at least puts it in the hands of the Postgres hackers, and we're not dependent on someone else who maybe doesn't care how it affects us. And the other thing I wanted to point out here, now, this signature is different, which you should expect, right? This is a different collation provider. It's going to give you a different actual ordering. But the thing that's cool here is, look at this, 17 seconds. So on RHEL 9, that sort took 56 minutes with the default collation. With Postgres 17 on the same laptop that I was doing the test, it took 17 seconds. And that's because it's doing basically a byte order comparison, and it doesn't have to worry about all of these complex rules for how characters get ordered. Now, at first blush, a lot of people in the community were like, well, but everyone needs to have their stuff ordered according to their locale rules, right? If you're in France, you care that things sort the way you expect them to sort. But the reality is, and Jeff was the one who kind of had the aha moment and pointed it out to the community, it's like most things that the database does, humans don't really care about the order, the actual order. It's just that the order is done consistently. So when you're doing a join, you're doing a lookup, those sorts of things, as long as the order is done in a consistent way, the operations work correctly. And they're so much faster with this. And if you really want that human readable order that looks correct to you, you can decorate your SQL query with a collate clause, or you can like take a specific column in a specific table and say this needs to be collated according to ENUS UTF-8 or something, right? If you really need that. Or probably more realistically, your app is querying data out of the database and you're only going to display 20 rows, and if they need to be ordered, just like order them in your app, right? So I would argue, my humble opinion, Postgres 17, start using the built-in provider, should provide you with stability going forward, and it's going to be a huge performance gain for at least certain use cases. All right, so any question about all that? I'm going to get to the last part of the talk. And I got 25 minutes, so I'm not doing too bad. So this is the look behind part. This is how do you deal with this problem for the existing stable releases, because not everyone's going to be able to jump to Postgres 17 right away. And you might have a database on Postgres 15 that you want to keep on 15 for another 5 years, and you're going to be forced to upgrade your OS, and so what do you do about it? Well, we created a library called Compat Collation for glibc. It's on GitHub, it's open source. And basically what it is a method to extract just the locale code out of glibc and preserve it into its own library that you can then link with Postgres. And critically, it's portable enough that you can take the library that you created on RHEL 7, it packages it up as an RPM, and you can install that RPM on RHEL 9. And we also have done this for Amazon Linux as well. I've created one for Amazon Linux 2 that is portable to Amazon Linux 2023. And so if you're running on RHEL 7 and you want to preserve that order, when you go to RHEL 8 or RHEL 9, you can use this to do it without having all your indexes broken and without having to worry about all the problems that we've been talking about. And so it's not like the permanent solution, but it could be a solution for like the next 5, 6, 7 years, potentially, if that's what you need. Now, generally, I would recommend that this thing be compiled in at build time for Postgres. It's actually possible to use it as a preload, which means you don't even have to recompile Postgres to use it if you build it that way, and I'll show you it's just kind of a one-line change to the build script. So this is how you would get it and build it. So if you clone that repository and you check out, there's basically 2 branches. When you go to that repository, just to show you the repo, if you go to the main branch, it's going to look like this thing is like empty. There's like a little bit of a README here and like nothing else there. And it was just the way it made sense when we were figuring out how are we going to do this for different versions of glibc that we want to let you build. And so you really need to check out one of the 2 branches that are there. If you have needs to preserve glibc for something different, you could basically create your own branch and follow what we've done and create one that preserves like glibc 2.28 from RHEL 8 if that's what you need to do. Just as a heads up, when I did the conversion from AL2 to RHEL 7, I think that took me about 2 days part-time to make it work. So it's not like zero effort, but it's not a moon launch either. And so once you check it out, you check out the branch, and then there's a build script that's provided, and you just say build, and that'll produce an RPM. That RPM depends on nothing else, and it's been tested at least to install without problems on RHEL 8 and RHEL 9 if you do the RHEL 7 one. And like I said, the AL2 version will install on AL 2023. And I've actually taken the AL2 RPM, extracted the library from it, and dropped it on my Linux Mint system, which is Ubuntu based, and it just worked. So it's pretty portable, not tested on every variation of every operating system out there, but the main ones. So the way this works is the changes have been applied on top of a source RPM build. And you might ask, well, why wouldn't you just do it to the upstream glibc sources? And the reason is, if you've ever looked at how RPMs are built, there's typically a, where's the, oh, I'm in the wrong. So you'll see when you extract a source RPM, you'll see a sources directory and a spec directory. The spec directory holds the spec file, which is the instructions for how to build the RPM. The sources directory are all the sources that go into building the RPM. And what you'll see in these things typically is there'll be a tarball of the upstream, like, so here's the release tarball for glibc 2.17, right? But then there are hundreds, if not over 1,000 patches that get applied. So when you are running RHEL 7 with glibc 2.17-326, there are 1,000 patches that are applied on top of the upstream code. And one of the things that Jeremy found and others have found is that even patch changes to an existing major release of glibc on occasion will change sort order. So the idea was that when we preserve this collation version, we want to do it not just to 2.17, but to 2.17-326, because that is a very specific patch version of glibc. And so there are two kind of distinct changes to the RPM source that we made. One was to the actual glibc source code that was pretty minimal, and the rest of it is basically packaging changes or building changes. So the goal was to minimize the changes to the source code, and there are really kind of four categories. glibc hard codes a bunch of assumptions about paths to where to find files, which is not very pretty, but they do a lot of that. And so that had to be changed so that we could have a separate set of directories for the locale files that we need that feed into how the collation works. And then we wanted anything that was not directly related to locale needed to be drawn from libc.so rather than be compiled into the library in order to keep that library portable to other OSs. And there's some technical reasons for that, in part because glibc, when you build it, libc and ld.so, which is the dynamic loader, end up having common structs. And if you include some of the really low-level glibc stuff in this library, it ends up being kind of pinned to the version of LD, and then when you move it, you have a different version of LD and things kind of go haywire. And then there were some symbol versioning issues that had to be resolved, and then this new get libc version is the way you get version, and I modified that specifically to add the extra patch information to the version string that is returned. So the building code, we had to modify the spec file, and for the custom build support, there's this, this is kind of interesting if you wanted to dive deep into this, but this build files will show you all of the glib source files that were extracted out of glibc to create this library. So if you're interested in knowing which parts of glibc are locale related and pulled into this, that just gives you basically a list of file names. And then there's a map file, which is the C symbols that are needed, and then the actual makefile script. Now, in that script that builds, if you wanted to do preloading instead of linking against Postgres, there's a one-line change you'd have to make. This enable LD preload is set to 0. You change it to a 1. And basically what will happen is the symbol versions will retain the glibc versioning instead of the compat library versioning, which allows you to preload this library instead of linking it. Okay, so lessons learned. I talked a little bit about this, but this performance regression is like significant and hardly anybody talks about it. It's like all modern versions of glibc still have this regression. It's really kind of strange. And I've talked with some people on the Postgres mailing list, and one guy pointed out that someone had gone to glibc and like complained about it, and they basically did nothing, and that was like 3 years ago. But in any case, there's just as an aside, the link is here. I just find this kind of funny. Can you read that? This is the commit message that caused the regression. Improve performance by removing a cache. So this guy went through this big analysis where he kind of proved to himself at least that what he was doing was going to improve performance. But at least for certain use cases, it's horrible. And like I said, the glibc people, I mean, basically what they said the last time someone asked was, well, there's kind of like no one maintaining string call anymore, and so, we're not going to fix it because we don't have anyone to fix it. So in any case, by using this compatibility library, you can use the older version of glibc, which doesn't have that performance regression, and so you get all that performance back. And then the other lesson learned, I had a bunch of, when I first gave this talk, I gave a bunch of lessons learned about what things I discovered as I was developing this library, but those are really not really relevant anymore. I think the most relevant thing is it just plain works. It's widely deployed in the Amazon Aurora and RDS Postgres fleets, like significantly widely deployed, and has been, basically it's been there in all the versions for roughly the last 2 years, and it just works. So, I mean, this is not like theoretical. This is not a project to do a proof of concept. This is being used very successfully every day by people all over the world. And I put a link in here to a blog that was written by Jonathan Katz, if you know him. When we first put this thing out, he wrote a nice blog that talked about how collation works and why this stuff is important, and then sort of says, oh, by the way, we deployed this library, so you don't have to worry about this stuff anymore. So how would you use this once you create the RPM? Basically, you'd build that RPM on a RHEL 7 system if you're doing the RHEL 7 branch. You would build it on an AL2 system if you're doing the AL2 branch. If you wanted to create one for whatever RHEL 8, you would build it on RHEL 8, but you'd take the RPM, you'd install it on RHEL 9, and then when you compile Postgres, you say libs equals, and you point to that library, and then you just do a make and make install. The Postgres server would work perfectly after that with the Collation library installed. There are a few things with the client applications that don't quite get compiled perfectly without a patch, which I've also made available on my website. Should probably address this upstream at some point. It's some makefile filtering that is kind of overly zealous that we should fix. But it doesn't affect Postgres itself, and so if you're running Postgres on your server, you're probably not using those client applications there. And then when you test it out, you're on a RHEL 9 system and you see the RHEL 7 ordering, and you try and insert a duplicate key, and it basically Postgres catches it, which is what it should do. And go back to Jeremy's question, when you query that actual collation version, this is the way it shows up. which is basically exactly what the RPM that the library was built off of. And so if you run the query, again, on RHEL 9, we're back to our 3-minute timing, which shows you get that performance back. And we're also back to our original signature, that E130, which is the glibc 2.17 ordering. And if you check the indexes, they're going to be clean. The end of this slide here, this is only if you're interested, but one of the things I wanted to do as I was developing that library was, how do you make sure that Postgres is actually using the symbols from the library, not the ones from glibc? And so there's a couple of scripts here at the end. I won't describe how they work in any kind of detail, but if you wanted to play with this yourself and you want to convince yourself that Postgres is actually using those symbols out of the library versus the glibc, these scripts would help you do it. So in summary, we talked about the problem, we talked about a couple ways to fix it, and I think I have about 10 minutes for questions. Or 9. Which function? Oh, okay. This one. Oh, okay. It was right there.
So the reason to not contribute this to glibc is basically, the reason it has to be done as part of the Red Hat package is because there are so many other patches and fix-ups that go with it, right?
I'm not sure. That's the reason it was built the way it was. I'm not sure that's a reason not to contribute it upstream to glibc. I've not tried that because based on everything I've heard about the glibc community, I don't have a great deal of confidence that they would care or do anything with it if I submitted a patch. Now, the methodology to extract the stuff that's important out into its own library could go upstream, and so future versions of glibc could actually produce a portable library like that, if we submitted the patch and they were to accept it. But I suspect that if I did submit that, they would want me to start maintaining it in glibc, and I'm not sure I'm ready to take on becoming a glibc maintainer. So theoretically, we could upstream it. It is all open source, and it could be upstreamed.
There's not currently a good way to get that to work on a Debian-based OS, right?
I didn't go through the work to figure out how to get it to work with a Debian package, a deb. But if you wanted to work with me to figure it out,
I don't know if there's really demand for that, just in terms of testing or just trying it out, makes it a little bit more convenient. I'm not sure it would be worth the work to actually do it.
Yeah, like I said, what I actually did was I took the RHEL 7 RPM that I built, and then I used whatever it is, RPM to CPIO, and then I basically used CPIO to extract the files, and then took the relevant files and just dropped them onto my Linux Mint system and compiled, and it works. So I've done that. It's just kind of manual. I've never built Debian packages. I think they're a little bit more like kind of tarring something up into a package rather than sort of what the Red Hat spec file does, where but I don't know that much about them, and I haven't had no one's come to me and said, we really want to build a Debian package equivalent for this. So, but I'm open to it. If someone needs that and wants wants help getting going, I'd be happy to work with them.
So glibc is like a Unix story, right? So do you know how that kind of things are handled in Windows world? Do they have like the same problems with collation and all of
I
it?
have heard over the years of problems with collation with Windows. I don't know if they've had the same issues with ordering changes, but I'd be willing to bet lunch that there probably is. I'm not sure I'd bet a paycheck, but I'd bet lunch.
I don't know too much about it, but I think they might be a little bit more careful about some of the changes. Just, you know, it's still dangerous. What is the sort of long-term story for this? Is it that we should use ICU for cases where they care about?
Well, I think the long-term story is if you can use the built-in collation that Jeff just committed to 17, that would be my first choice. If you need more sophisticated functionality, then ICU would be the solution.